Hello, my dear students. How are you? Hope you're doing fine. Today we're going to continue together Chapter 11 about ratio and proportion and percentages. We're going to take Lesson 2 of Chapter 11 today, which is about equal ratios. The lesson is on pages 648 and 649. The main objective of our lesson is to write a ratio in simplest form and to write other equal ratios to a given ratio. So our plan is to learn how to write this ratio in the simplest form, how to write equal ratios, and we're going to solve questions from the student book. The same instructions as every time is to download the resources and open the book. Please open the notebook, write the date and the day and lesson 11.2 title. Follow the instructions and you can repeat watching as much as you want. Solve the questions from the student book on the notebook as the slides mention. Let's start with this quick warming up. We need here to compare by writing smaller than, bigger than, or equal for each pair of fractions. Remember, when we need to compare fractions, we should have the same number in the denominator. So in number 1, it's 3 over 10. Number 2 is 30 over 100. The denominators are 10 and 100. They are different. We should make them the same. How can we turn 10 to 100? Of course, the only way of doing that is multiplication or division, but generally we use multiplication. So 10 multiplied by what equals 100? Yes, you multiply it by 10. So when you multiply the denominator by a number, you should do the same for the numerator. So 3 times 10 and 10 times 10, we get 30 over 10. 3 times 10 is 30, and 10 over 10 is 100. So it's 30, and the other fraction we have 30. So they are equal. Look at number 2. In number 2, we have 3 over 10 and 5 over 10. They have already the same number in the denominator, 10, 10. So just look at the numerators. Which number is bigger? 5 is bigger. So 5 over 10 is bigger than 3 over 10. If you look at number 3, we have 2 over 3 and 5 over 6, different denominators. We look at the smaller one, which is 3 here. Can we multiply 3 by any number to get 6? Of course. We can multiply 3 times 2, and we do the same for the numerator. So we get 4 over 6, which is now 5 over 6. Now 5 over 6 is bigger than 4 over 6 because 5 is bigger than 4. Well, let's start talking about simplest form of ratios. How can you write a ratio in simplest form? If you look at this ratio, 18 to 24, we need to write it in simplest form. Do you remember in the previous lesson, one way of writing this ratio is a fractional form? We can write, first of all, 18 to 24 as a fraction. And when we write it as a fraction, the first number up, 18 over 24. Now, exactly the same way of writing the simplest form of the fractions. We look now at 18 and 24. So, how to write the simplest form of the fraction? Do you remember that from lesson 710? We need to think of the greatest common factor of 18 and 24. And to find the greatest common factor of 18 and 24, we need to find or write all the factors for each of them. What are the factors of 18? We know there's 1 and 2 and 3 because 1 times 18 is 18. 2 times what is 18? 2 times 9. 3 times what is 18? 3 times 6. And 1 times 18 is 18. So these are the factors of 18. And the factors of 24, there is 1 times 24 is 24. There is also 3 times 8 is 24. And there's also 12 times 2 is 24. And 6 times 4 is 24. These are all the factors of 24 and all the factors of 18. What's the common one, the greatest common one? Think of it. The greatest common one is, yes, it's 6. So now, if you continue doing that, step number 2, after finding the greatest common factor, you divide the numerator and the denominator by that common factor. So 18 divided by 6 and 24 divided by 6 is 3 over 4. That is the simplest form of it. So let's do another example now. Simplifying ratios without writing the ratio as a fraction. Look at these blocks here. The ratio of yellow to green blocks is the yellow are, let me first fix this one here, the green gray blocks to yellow blocks. So if you compare, or if we need to write the gray blocks to yellow blocks, it's 4 gray blocks to 2 yellow blocks. We need to write this in simplest form without writing the fractions. No need to write every time your ratio as a fraction. So you can just keep it as is with the columns. So here, 4 to 2. Look at 4 and 2. What is the greatest common factor between 4 and 2? We know the factors of 2 are 1 and 2 only. The factors of 4 are 1 times 4, so 1 and 4, and also 2, which is 2 times 2 equals 4. So the common factor between 4 and 2 is 2. So look, we're going to divide 4 by the 2, and we divide 2 by the 2. 4 divided by 2 is 2. 2 divided by 2 is 1. So this is the simplest form. Let's do more examples. We need to simplify the following ratios. Now, 5 to 10. How do we simplify this? We look at the common factors between 5 and 10. The simplest form between them is to look at the common, which is 5. We can divide by 5 by 5, and we can divide 10 by 5. What do you think we get if we divide them by 5? So 5 divided by 5 is 1, and 10 divided by 5 is 2. Let's have another example, 7 to 21. The common factors between 7 and 21 is 7, so we divide 7 by 7, which is 1, and 21 divided by 7 is 3. So this is the simplest form. One more example. 12 to 8. What is the common factor, or the greatest actually common factor between 12 and 8? The greatest common factor between them is 4. Excellent. So 12 divided by 4, 3. 8 divided by 4 is 2. Number 4, we have 6 and 15. The greatest common factor between 6 and 15 is 3. Yes, you need to think of the factors of each of them. If you can't figure that directly, just list your factors for each number you have. So the factors of 6 are 1, 2, 3, and 6. The factors of 15 are 1, 15, 3, and 5. So the common factor between them are 1 and 3, but the greatest one is 3. So we divide each one by 3. 6 divided by 3 is 2, and 15 divided by 3 is 5. So this is how we write the simplest form of the ratio. See, it's exactly as the fractions, but it's different by just the way of writing the ratio. Now, we're going to talk about equal ratios. Equal ratios means they show the same comparison. Look, you can use multiplication or division to find other ratios that are equal to 9 to 15, for example. It's exactly like equivalent fractions in lesson 7-8. So you can go back to that lesson and remember how we do it. Anyway, I'm going to remind you about it now. If we want to use multiplication, remember that you can multiply both numbers by any number you want except 1. So we can, for example, choose 2 and multiply both numbers by 2. See, both numbers by 2. We can't multiply 9 by 2 and 15 by a different number in the same time. We should choose the same number. So 9 times 2 is 18, and 15 times 2 is 30. So 18 to 30 is an equal ratio to 9 to 15. Can we write another equal ratio by using multiplication? Of course we can. You can choose 10, for example. I can multiply them by 10, so you will get 90. 15 times 10 is 150. So 18 to 30 is one equal ratio. 90 to 150 is another equal ratio to 9 to 15. Can we write more equal ratios by multiplication? You can write infinite number of equal ratios. You can multiply them both by 3, 4, 6, 100, million, whatever you want. By the way, we can use also division. Look at 12 to 36. We need to use division to write equal ratios for 12 to 36. We divide both numbers by not any number we want. But you have to be careful in division that when you want to divide, you choose a common factor between the numbers. So this is 12 to 36. We can, for example, divide them both by 2, since both of them are even numbers. 12 divided by 2 is 6. 36 divided by 2 is 18. So this is one equal ratio. Now look at 12 and 36 again. Is there another number that you can divide them by? Yes, we can divide them by 4. We can divide them both by 6. We can divide them both by 12. So here we choose, for example, 6. 12 divided by 6 is 2. And 36 divided by 6 is 6. So these two ratios, 6 to 18 and 2 to 6, are also equal ratios. Now look, a statement that two ratios are equal, we call it proportion. Do you remember in fractions when two ratios are when two fractions, are equal, we used to call them equivalent fractions. Now in ratios, when we have two equal ratios, we call them proportion. So proportion means that the two ratios are equivalent or equal. How to tell if two ratios are equal or perform a proportion? Look, 25 to 15, we need to decide if 25 and 15 is equal to 20 and to 20 to 12. The only way to decide that is to find the simplest form of each ratio. So let's start with the first one. To tell if they are equal, we write the ratios in simplest form. 25 to 15. To write this in simplest form, we divide by the greatest common factor. So what common factors do we have between 25 and 15? Yes, we can divide them both by 5. So 25 divided by 5 is 5, and 15 divided by 5 is 3. So this is the simplest form. Look at 5 and 3, they have nothing in common except 1, so they are in simplest form. Let's go now to the next ratio, 20 to 12. What is the common factor? It's 4. 20 divided by 4 is 5, and 12 divided by 4 is 3. This is the simplest form. Look at both simplest form. Are they the same? Yes, they are exactly the same. So here, both 25 to 15 and 20 to 12 have the same simplest form, so they are both performing a proportion. They perform a proportion. Just a question, is 5 to 3 the same as 3 to 5? If we get 3 first, then 5, are they forming proportion? No, they don't. They should be in order. Remember that ratios should be written in order. Let's now do some practicing from the course book, page 649 and 650. Please do these questions in your notebook. You have only 4 minutes to do them. You can pause the video. Once you finish solving them, click continue to continue watching that. You need to write here the simplest form for each of these questions. Let's check the answers. Number 1, we divide 15 and 5 by 5 to get this simplest form. 49 to 21, the greatest common factor is 7. So when you divide by 7, you get 7 to 3. Number 13, 13 to 39, we can divide each of them by 13. So 13 divided by 13 is 1, and 39 divided by 13 is 3. In number 14, 24 to 60, the greatest common factor is 12. So 24 divided by 12 is 2, 60 divided by 12 is 5. Okay, you're gonna have now another 4 minutes to do these questions by giving 2 equivalent ratios. So, let's check the answers. Remember that your answers might be different than our answers. It depends on the numbers that you choose to write equivalent ratios. So here in the first one, we multiplied by 5 and then by 4. Number 8, for example, I choose division, then I choose multiplication. In number 19, we choose division, dividing by 2, and I choose, for example, times 10 then. In number 18, we multiplied by 3 first to get 15 to 24, and we can choose multiply by 7. So your answers might be actually different than our answers. But that doesn't mean that they are wrong. If you are doing the correct operations, that means your answer is correct. Now, another 4 minutes to do questions 22 and 24. Here, you need just to tell, are the ratios in each pair equal? So, to decide if they are equal or if they form a proportion, you should write the simplest form of each one. Take your time. Once you're done, you can click to see the answers. Let's see the answers. 5 over 25. We can divide 5 and 25 by 5. So, when you divide by 5, you get 1 over 5, which is the same as the other one, 1 over 5. So yes, they are equal. But in number 24, if you simplify 5 over 10, divide each one by 5, you will get 1 over 2. And here, the simplest form of 16 over 40. 16 divided by 8 is 2. 40 divided by 8 is 5. So look, 1 over 2 and 2 over 5 are not equal. So they are not performing a proportion. So that was our lesson. Remember that you can repeat watching the lesson as many times as you want. Now you have a homework. This is your homework. It's according to the links that you see. Your homework is due Saturday, not after 2:30 p.m. Thank you for watching and Ramadan Kareem.